Okay, the video that we're watching now is part of the Chapter 7 test review, and we're going to do all of the equations that require us to solve for x using exponentials or logs. And in this case, we really just need to convert everything to an exponential. In other words, I'm writing everything as an exponential. Remember that if I make the bases the same, then I can actually ignore these two 10s and actually just set 4x minus 1 equals 3. So I took 1,000 and I wrote it as 10 cubed. When you write the number, this is actually very important. What people will do is they'll multiply this 10 by something to make 1,000. You don't want to make the number bigger. You want to keep these numbers as bases. So this 1,000 can be written as 10 cubed. Okay, so now I'm going to say it a different way. What you want to do is you want to keep the equation the same. So in other words, I don't want to change the number. 10 cubed has not changed the equation. 10 cubed is still 1,000. I'm writing it just as an exponential that represents 1,000. Okay, therefore the two 10s, I can cancel them out, and I can keep going here with 4x minus 1 equals 3. This becomes really easy because you add 1 on the other side, and then I realize, oh, x is just equal to 1, and that's my answer. I will check every problem in this video, but in this case, x equals 1 is not going to affect anything. It's just an exponent, so it's fine. Okay, here's number 32. We have 5 to the x equals 32. So I'm going to go and do the conversion of what I normally remember, or I normally remind everybody, is 2 cubed equals 8. And if I can convert backwards and forwards to log 2 8 equals 3. This is what I always remember. And in fact, it might be important just to write something like this on your paper right when you get the test. Okay, just memorize it, write it down, and then you can use it for every equation, okay, or every problem. So in this case, I went ahead and I converted from this exponential to a log, and then I get log 532. As soon as you get this is what you need to tell yourself. It's important to think, hey, wait a second, I can put that in the calculator. So I'm going to do log 32 divided by log 5 using the change of base rule. So then I've got x equals 2.153. Again, round to 3 decimal places, okay? All right, so number 33, I have 2 e to the x minus 1 equals 9. Now I've got extra stuff, okay? I want to be able to convert, but if you have extra pieces, then you're not going to be able to convert it to the log or an exponential. So you want to get rid of the 1, which makes it a 10, and then you want to divide by 2, which gives you e to the x equals 5. So now I've got all the pieces in place. I can convert from a exponential to a log, which in this case is log base e of 5 equals x, which is really just natural log, right? I can use the natural log button in the calculator, enter a 5, and then press the enter key, and I get x equals 1.609. Okay, next problem, number 34. We have log base 4 of x equals 2. Again, I'm going to look to see that all the pieces are in place because I want to convert this to an exponential. Okay, so I'm going to go 4 to the second equals x, which x is just 16. Easy problem because there weren't any extra pieces. I could just convert, boom, done. Okay, number 35. You have log base 3 of 2x minus 5 equals 2. Now there's extra stuff in here, but see this 2x minus 5? It belongs all together. It's all one piece. So I really have all the pieces in place. I have a base, I have a result, I have an exponent. So I can go 3, which is my base, to the exponent, which is 2, equals 2x minus 5. And now I can just start solving. So if I add 5 over to the 9, I get 14. divide by 2, and I get x equals 7. Always remember that we're going to check to make sure that this number does not make a negative in here. If you take the 7, put it back in here, you get 14 minus 5 is 9. That's a positive number. It's all going to work. Okay, and for our purposes in this test, this number will never make a negative here. Okay, so make sure that you do not get a negative, that this piece does not make a negative, or else you will have an extraneous solution, something that's not valid. Okay, number 36. We have natural log of 3x equals 5. Now, just so that you can see it, I like to write out that the natural log is log e, so that you can see when we convert it to an exponential, it's going to be e to the 5th equals 3x. Notice the 3x was a multiplication, so you can look at that and say, wait, that 3x is supposed to be all together. Okay, no extra pieces on this. We get 148.413 equals 3x. If I divide by 3, my answer is 49.471. Okay, number 37. We have 2 times the log of base 5 of x minus log base 5 of 2 equals log base 5 of 2x plus 6, which is all together. Okay, as soon as you see 2 logs that are together on one side, you're basically going to have to condense it. This is where you got to bring those condensing rules back into what you're doing here. This is going to be x squared divided by 2. Notice that changes to divide, and that becomes an exponent right there. So I've got log 5 of x squared over 2 equals log 5 of 2x plus 6. Remember that if you have a log on both sides, really means that you can take these pieces and just set them equal to each other. Okay? You just want to know what x is, so you just take everything out, go x squared over 2 equals 2x plus 6. I don't like that divide by 2. Let's multiply it on the other side. So I get x squared equals 4x plus 12. I'm going to subtract the 4x and the 12 over because it's an x squared. I'm going to have to factor. It's a quadratic. Okay? So x squared minus 4x minus 12. So I'm going to factor that as x minus 6, x plus 2. That'll give me the negative 4x in the middle and the minus 12 at the end. So I get x equals 6 and x equals negative 2. Guess what? That negative 2 will work there, and I don't care about it there, but it will not work there. Negative 2 is going to give me an error in the calculator. So the answer is x equals 6. You better check all of your solutions in the log to make sure it doesn't give you an error. That's very important. Okay, log base 6 of 2x minus 6 plus log base 6 of x equals 2. This is number 38, and we are condensing again. Yes, you are going to have some of these problems on the test. When I condense, I don't like this x over here. I'm going to put it in the front. Okay, so the plus sign changes to a multiply. Okay, notice there's my multiply right there. I'm going to convert it, so it's 6 squared, 6 to the 2 equals, and go ahead and multiply this out. So I've got 2x squared minus 6. And then notice right here what I did. See this 6 squared? I went ahead and subtracted it on this side because it's a quadratic. I'm going to have to factor it, right? So I might as well make this side, go ahead and make this side 0. There we go. So now I'm going to take out a 2 because I can tell there's a 2 inside of all these numbers here. So if you take out a 2, you get x squared minus 3x minus 18, which is going to make it easy to factor. By the way, all the problems on the test will be easy to factor. Okay, you just need to get to this point. If you can get here, I'm going to know what you're doing. All right, x minus 6, x plus 3. So the answer is x equals 6, x equals negative 3. Wait a second, the negative 3 doesn't work because that'll make an error in the calculator because there's no way that 6 can make a negative. So your answer is x equals 6. All right, so we're up to 39. 39 is 3. E to the 3 minus x, which means that whole piece is together, 3 minus x. Even though there are no parentheses, you need to consider that that's all one exponent. That 3 is extra. Let's divide it over because I don't need that. So I've got e to the 3 minus x equals 5. And now I have my pieces in place. Let's write log e of 5 equals 3 minus x. Remember, log e is just the natural log button in the calculator. So I'm going to do ln button 5 and I get 1.609. I'm going to go ahead and subtract that 3 over because that makes it easy. And I get negative 1.39 equals negative x. If you divide by negative 1, you get a positive, which means the answer is 1.39. And that number works just fine in the exponent over here. Okay, 40. We have 2 times log base 7 of 1 minus 2x equals 12. I have some extra pieces going on right here. I don't want that 2 over there because I won't be able to convert. So I'm going to divide the 2 over on the other side. That'll give me 6. So now I have log base 7 of 1 minus 2x. Notice the 1 minus 2x is all one piece. It's in parentheses. Okay, so now I'm going to convert it to an exponential, which is 7 to the 6 equals 1 minus 2x, 7 to the 6, right there. That's going to give me a big number. 117,649 equals 1 minus 2x. Subtract the 1 over, that'll give me an 8. And then I'm going to divide by the negative 2. So the answer is x equals negative 58,824. Yep, if the number seems weird, you need to go with it. Okay, last problem for this video. Number 41. This is another one of those exponential problems where both sides are an exponent and we're just going to convert. I'm sorry, let me rewrite it. Let me say it differently. 25 is going to be written as 5 squared. Okay? I'm going to say it one more time. I already said it on the previous problem like this. But again, do not change the equation. Notice the equation has not changed. It's very important. Don't take this and make it 5 squared in order to get 25. Yes, I have seen students do that before, and it's natural to think that way. It's okay, but that changes the equation. You don't want to change it. You want to write the equation and keep it the same. This is 25. This is 25. I have not changed the equation here. I am simply saying 5 squared so that I can have the same bases, right? Once I have the same bases, then I can ignore the bases and I can go 2 times x minus 4 because those are exponents. If this is an exponent and this is an exponent, I have to multiply, right? And I have 3x plus 1, so I'm going to distribute. I'll get 2x minus 8 equals 3x plus 1. I'm going to subtract the 2x on the other side, which will give me an x. And then I'm subtract the 1, which will give me negative 9, so x equals negative 9. Okay, that is all of the equations where we have to solve for x using an exponential or a log. If you have any questions, please feel free to ask. Thanks for watching.